the fifth chapter in IB Chemistry is energetics. In 5.1, you're supposed to be explaining about the endothermic and exothermic reaction. So you should explain to your student what they mean. For example, endothermic is a net release of energy from the reaction and stuff like that. And you need to also tell them about the temperature of surroundings. For example, endothermic reaction will cause the surrounding temperatures to increase and it will feel hot. You need to talk about the relative energies of products and reactants. Like in endothermic reactions, the products will have higher energy or greater total energy than the reactants. And then you also need to talk about the energy diagram. Okay, something like this. This is energy. This is reaction pathway. And exothermic will be like that. Reactants, products. And this will be your delta H. Okay, so you need to explain this for both endothermic and exothermic reaction. And about the delta H, how it is positive for endothermic and negative for exothermic. Okay, that's for the first part. In the second part, calculation of enthalpy changes, it mainly involves these two equations. One will be Q is equal to mc delta T, and delta H will be equal to Q over number of moles. Okay, so here you need to be explaining about how usually the Q will be measured based on water or the medium. Okay, on how we can't really measure the temperature of the reactants, but we can measure what the changes in the environment, and from there we can deduce what's happening in the reaction. For example, in endothermic reaction, I made a mistake. Just now I mentioned it becomes hotter if it's endothermic, it's actually cooler. So, like for example, in endothermic reaction, when the reaction happens, the surrounding or the beaker will become cooler because the energy from the water has been absorbed by the reaction. That's why it's an endothermic reaction. So based on that, you can explain that the mass will be about the mass of the water, and C, which is specific heat capacity, will also be of the water. Okay, we will, of course, like assumptions like we are going to ignore the reactions because they are very dilute and stuff like that. Okay. 5.3 is Hass's law. So first you have to define what this is. Although the students are not required to know the definition, but you can tell them. And most importantly, you need to teach them the application. Teach them the application of Hass's law. Okay. So Hass's law states that if you start with the same reactants and you end with the same product, okay, doesn't matter which path you take, you will have the same enthalpy change of reaction. Okay, so that's Hass's law. Usually we will teach two methods. One will be the algebraic method. Another one will be energy cycle method. Okay, it's good for students to know both, and the example can be found in the notes. Okay. Now for bond enthalpy, you need to define average bond enthalpy. Okay, and again, this is about application. So your students will be given reactions. Okay, so reactions, and then they will need to be able to know like that how to like how bond breaking is endothermic and bond forming is exothermic. Okay, so based on this, when you're given a reaction, okay, the students need to know that all the bonds in the product will be broken and all the bonds in the reactant will be formed. Okay, so you'll have positive value of bond enthalpy here and negative value of bond enthalpy here, and to find the enthalpy, overall enthalpy change, you just have to add the here and here. Okay, you can take this and minus it off the bonds broken. Okay, so just take note that the students need to remember that to use your bond enthalpies, all your molecules must be in gaseous states or in gaseous state. Okay, so this is like one of the questions that they can ask, like if there's a difference between the calculated value and the real value and stuff like that.